Good morning to all. Today we shall discuss important article, that is unit 2, matrix and determinant. First we shall discuss matrix. Is a very important, also very easy unit. A student can score highest mark in this unit. That is unit 2. Unit 2. Matrix and determinant. First, we shall discuss about the matrix. Matrices. What do you mean by matrices? And what is its uses or its application? Suppose there are 4 matches. Match 1, match 2, match 2, match 3, match 4. There are 4 matches, match 1, match 2, match 3, and 3 players. Suppose Virat Kohli, MS Dhoni and Sachin Tendulkar. 3 players. Suppose in match 1 Virat Kohli scores 36, MS Dhoni 25, Sachin Tendulkar 57. Similarly in match 2 Virat Kohli scores 89, MS Dhoni 75, Sachin Tendulkar 26. In match 3 Virat Kohli scores 56, MS Dhoni 35, Sachin Tendulkar 59. In match 4 Virat Kohli scores 57, 82 and Sachin Tendulkar 85. Then we can arrange them in a row and column. That is, we can write as 36, 25, 57 and 89, 75, 26, 56, 35, 59, 57, 82, 85. We can arrange them in row and column. This row represent the score of the 3 players in match 1. One can easily find the score of the MS Dhoni in match 1, that is 25. That type of arrangement is known as matrix. Matrix has no value, only the arrangement. So, arranging for some data in a row and column is known as a matrix. Particularly, matrix is the rectangular array of numbers or element. Matrix is the rectangular array of numbers arranged in rows and columns. So matrix is a rectangular array of numbers arranged in rows and columns. That is the definition of the matrix. Matrix is only arrangement. Arranging some data in a row and column is known as a matrix. One can easily find the data from the arrangement. That type of arrangement is known as matrix. Suppose a matrix is arranged A11, A12, A1n, A21, A22, A2n, AM1, AM2, dot dot AMN. This is a matrix which has m rows and n columns. It has m rows and n columns. It has m rows and n columns. So its order will be m cross n. The order of the matrix will be m cross n, and this is a matrix of m by n. Also it is known as the matrix of order m by n, or it is a matrix of order m cross n, because it is m rows and n columns. That if Aij means the entry in ith rows and jth column. First suffix represent for row and second suffix represent for column. So Aij is an entry or element in ith row and jth column. Similarly, A11, it is an entry in first row and first column. This is an entry in first row, second column. This is an entry in first row, nth column. Particularly, suppose a matrix represent as 1, 2, 3, 4, 5, 6. This is a matrix which has 2 rows and 3 columns. So its order will be 2 cross 3. It is a matrix 2 by 3 or 2 cross 3 because it has 2 rows and 3 columns. If I ask which entry is A23 entry is 6. That is second row and third column. That is 6. So in generally we write a matrix A as Aij of order m cross n. Means A is a matrix of order m cross n, means it has m rows and n columns. This all about the representation of a matrix and its order. Here, what do you mean by matrix and its order and elements of a matrix we can find easily. Then we will discuss about different type of matrices. Different types of matrices. Different types of matrices. First, what is row matrix? Row matrix. A matrix which has only one row. A matrix which has only one row is called a row matrix. A matrix which has only one row is called a row matrix. A matrix which has only one row is called a row matrix. For example, 1, 2, 3, 4. This is a matrix which has only one row but 4 columns. So its order will be 1 cross 4. That is a matrix of order 1 cross 4. Means it has only one row and 4 columns. That is known as a row matrix. Next, column matrix. Column matrix. A matrix which has only one column. Only one column is called a column matrix. A matrix which has only one column is called a column matrix. For example, we can also represent matrix as this type: 1, 3, 5, 7. It has one column, 4 rows. So its order will be 4 cross 1. First represent the number of column and second represent the number of, first represent number of rows, second represent number of columns. So this type of matrix is known as row matrix and this is column matrix. Next, what is zero matrix or null matrix? Zero matrix or null matrix. Zero matrix or null matrix. A matrix whose all entries are zero is called zero matrix. A matrix whose all entries are 0 is known as zero matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0. This is a null matrix of order 3 cross 3. Because all the entries of this matrix are 0, so it is called a null matrix or zero matrix of order 3 cross 3. It is a null matrix of order 2 cross 3. All the null matrices are not equal. This is a null matrix of order 3 cross 3 and this is a null matrix of order 2 cross 3. This is a null matrix. Next, square matrix. Square matrix. A matrix A we represent it as Aij of order m cross n is said to be square matrix. Is said to be square matrix if m equals to n. That is, if the number of rows equals to number of columns, then we say that it is a square matrix. Square matrix has equal number of rows and equal number of columns. That is known as square matrix. For example, suppose A is a matrix of 1, 2, 3, 3, 2, 1, 4, 5, 6. This is a square matrix of order 3 cross 3. Because it has 3 rows and 3 columns, equal number of rows and equal number of columns, so it is known as a square matrix. Then it is rectangular matrix. Rectangular matrix. A matrix A represented as Aij of order m cross n is said to be rectangular matrix. Rectangular matrix if m not equals to n. If the number of rows and number of columns are not same, then in this case it is said to be a rectangular matrix. For example, 1, 2, 3, 3, 2, 4. It is a matrix of order 2 cross 3. It is a rectangular matrix, but it is a square matrix because here the number of rows equals to number of columns. But here number of rows is 2, number of columns is 3. So it is not a square matrix. It is a rectangular matrix, but it is a square matrix. Then diagonal matrix. What do you mean by diagonal matrix? Diagonal matrix. A square matrix is said to be diagonal matrix. It must be a square matrix. A square matrix is said to be diagonal matrix if Aij equals to 0 for I not equal to j. A square matrix is said to be diagonal matrix if Aij equals to 0 for I not equal to j. It is called a diagonal matrix. For example, 1 0 0 0 2 0 0 0 3. Here A is a square matrix of order 3 cross 3. It is known as A1 2. Here I is 1, j is 2. So I is not equal to 2, j. I is not equal to j. In this case the entry will be 0. Aij 0 for I not equal to j. Means the diagonal element are not 0, rest are 0. Is known as diagonal matrix. This is an example of a diagonal matrix of order 3 cross 3. This is also a diagonal matrix of order 2 cross 2. 2 cross 2. These are the example of a diagonal matrix. Then unit matrix. Unit matrix or identity matrix. Unit matrix or identity matrix. A matrix is said to be unit matrix if Aij equals to 1 for I equals to j and Aij equals to 0 for I not equal to j. In this case it is said to be a unit matrix. We denoted it as I. That is, I means unit matrix. A unit matrix of order n cross n denoted as In means it is a unit matrix of order n. Order n means n cross n. When it is a square matrix, we say it is a order n, means it is a matrix of order n cross n. So this is a unit matrix of order n. For example, 1 0 0 1. This is a unit matrix of order 2 cross 2. I equals to 1 0 0 0 1 0 0 0 1. This is a unit matrix of order 3 cross 3. These are all the example of unit matrix. Next, scalar matrix. Next, scalar matrix. Scalar matrix, a square matrix, is said to be scalar matrix. Scalar matrix if the diagonal elements are same and rest are all zero. A square matrix is said to be scalar matrix if the diagonal elements are same and rest are zero. For example, suppose A is a matrix 2 0 0 0 2 0 0 0 2. This is a scalar matrix of order 3 cross 3. Unit matrix may be a scalar matrix. All unit matrix are scalar, but odd scalar are not unit matrix. This is also a scalar matrix. This is also a unit matrix, but this is a scalar matrix only, but not unity. Unit matrix means the diagonal element 1 and the rest are 0. But this must be a square matrix. That is the minimum condition. A scalar matrix must be a square matrix. That is scalar matrix. Next, transpose of a matrix. Transpose matrix. Transpose matrix. Let A equals to Aij, a matrix of order m cross n. Let A be a matrix, be any matrix. Then writing rows of A as corresponding columns, and vice versa, those matrix we obtained is called transpose matrix. Transpose matrix of A. If we write corresponding row as corresponding columns and corresponding column as corresponding rows, thus matrix we obtained is called transpose matrix of A. We denoted it as a dash or A ऊपर हमें की भी दे परिवार. That is transpose matrix of A. Its order will be n cross n. If A is a matrix of order m cross n, then its transpose will be order n cross n. The ijth entries of A transpose will be Aji. Means if A is a matrix of order m cross n, then A transpose will be a matrix of order n cross m, and its ijth element is Aij, but its ijth element will be Aji. For example, suppose A is a matrix 1 2 3 2 1 4. This is a matrix of order 2 cross 3. Then its transpose matrix A dash or AT That is, first row will become first column. First row will be first column and second row will become second column. Then its order will be 3 cross 2. This is the transpose matrix of A. Its rows becomes its column. First row become first column, second row becomes second column. If it is a matrix of order 2 cross 3, then its transpose will becomes 3 cross 2. That is transpose matrix. Next, symmetric matrix. Symmetric matrix. A square matrix. A square matrix is said to be symmetric if A transpose equals to A. If the transpose of the matrix will itself same, then it will become a symmetric matrix. For example, suppose A is a matrix 1 2 2 1. Its order is 2 cross 2. Then its transpose will become same 1 2 2 1. No change. A dash or A transpose will becomes A. Then we say that matrix is a symmetric matrix. Next, skew symmetric. Skew symmetric. Skew symmetric matrix. A square matrix. A square matrix is said to be skew symmetric if A transpose equals to minus of A. Then in this case we say that matrix is a skew symmetric, but it must be a square matrix. For example, 0 1 2 minus 1 0 3 minus 2 minus 3 0. That is a skew symmetric matrix of order 3 cross 3. That is symmetric and this is skew symmetric. Next, idempotent matrix. Idempotent matrix. Idempotent matrix. A square matrix. A square matrix is said to be idempotent if A square equals to A. If the multiplication of A with A becomes same matrix A, then it is said to be a idempotent matrix. Next, nilpotent matrix. A square matrix A is said to be nilpotent matrix of degree n. Nilpotent matrix of degree n if A to the power n equals to 0 matrix. If the A square will be 0, then it is a nilpotent matrix of degree 2. If A cube becomes 0 matrix, then it is said to be a nilpotent matrix of degree 3. So, if the A to the power n equals to 0 matrix, then it is said to be a nilpotent. Next, orthogonal matrix. Orthogonal matrix. A matrix is said to be orthogonal matrix. Orthogonal matrix if A with A transpose becomes the unit matrix. If the multiplication of the matrix with its transpose matrix becomes the unit matrix, then it is said to be orthogonal matrix. Involuntary matrix. Involuntary matrix. A square matrix. A square matrix is said to be involuntary matrix. Involuntary matrix if A square equals to unit matrix I. If A square equals to unit matrix I, then it is said to be a involuntary matrix. These are the different type of matrices. There is also other different type of matrices, but in our +2 courses that is sufficient. Upper triangular matrix, lower triangular matrix, there are different Hermitian matrix, Q Hermitian matrix, there are different type of other matrices also, but in our +2 courses that is sufficient. Next, equality of two matrices. Equality of two matrices. When we say that two matrices are equal, since matrix has no value, so if two matrices satisfy the two conditions, then it is said to be equal matrix. Two matrices are said to be equal. Are said to be equal if first condition they have same order. They have same order. If A and B are two matrices, then first condition the order of A will be order of B. That is, they have same order. Number 2, the corresponding element. The corresponding element or corresponding entries of two matrices are equal. If two matrices satisfy these two conditions, then we say that two matrices are equal. For example, if x, y, u, v equals to 1, 2, 3, 4, then we say that x equals to 1, y equals to 2, u equals to 3, v equals to 4. First they have same order, then corresponding entries will be same. First row first column entry will equals to first row first column entry. Then second row second column entry equals to second row second column entry. Then we say that two matrices are equal. So that is the two required condition. By this condition we say that whether the two matrices are equal or not. That is the equality of two matrices. Next, algebra. Algebra of matrices. Algebra First, addition and subtraction. Addition and subtraction. Any two matrices cannot be added, also cannot be subtracted. There is minimum condition that they have same order. Two matrices, when we add two matrices, there is the minimum condition that they have same order. Two matrices, let Aij of order m cross n and B is a matrix Bij of order m cross n. Let A and B are two matrices. Then A plus B is also a matrix. Is also a matrix of order m cross n. After the addition or subtraction, the order of the matrix will not change. First minimum requirement that when two matrices we are going to add two matrices, we must first look out that they are same order or not. If they are same order, then we can add, also subtract. Without the same order, we cannot add or subtract two matrices. Its ijth element will be Aij plus Bij. For example, suppose A is a matrix 1, 2, 3, 2, 1, 4. Its order is 2 cross 3. And B is a matrix 2, 1, 4, 3, 2, 5. Its order is 2 cross 3. Now we can add A and B. Also we can subtract A and B because they have same order. How we can add? That is A plus B will be 1 plus 2. Corresponding element will be added to corresponding element. 1 plus 2, 3. 2 plus 1, 3. 3 plus 4, 7. 2 plus 3, 5. 1 plus 2, 3. 4 plus 5, 9. And its order will be 2 cross 3. That is the addition of two matrices. Similarly, A minus will be 1 minus 2 minus 1, 1 minus 1 minus 1 minus 1 minus 1. Its order will be 2 cross 3. After addition and subtraction, order will not change. We have to add the corresponding elements of the entries of two matrices. Also, we can subtract corresponding entries of two matrices. Then we can find A plus B and A minus B, and its order will not change. Order will be remains m cross n. This is all about the addition and subtraction. Fundamental properties. First, addition is commutative, means A plus B equals to B plus A. But subtraction is not commutative. A minus B is not equal to B minus A. Addition is also associative. A plus B plus C equals to A plus B plus C. Addition with zero matrix of same order will be same as matrix A. That is the fundamental properties. Next, scalar multiplication by a matrix. Scalar multiplication by a matrix. Scalar multiplication by a matrix. Let A equals to Aij, that is A is a matrix of order m cross n. Let K be any scalar. Means either K is a real number or complex number, any constant. Then K into A is also a matrix, of order m cross n. After the multiplication of the scalar, the order will not change. The ijth element will be Kij, means all the entries multiplied with K. That will be the scalar multiplication of the matrix. For suppose A equals to 1, 2, 3, 2, 1, 4. This is a matrix of order 2 cross 3. We have to find K. Or suppose 5A. 5 is here K. That will be 5, 10, 15. Each entry will be multiplied with 5. 10, 5, 20. Its order will be same as 2 cross 3. This is the scalar multiplication by a matrix. Properties: Ka transpose is same as Ka transpose. It's the fundamental properties, that is scalar multiplication by a matrix. Next, matrix multiplication. Matrix multiplication. We cannot multiply any two matrices. There is a minimum condition which matrix will be multiplied with which matrix. Let A equals to Aij of order m cross n and B equals to Bij of order P cross Q are any two matrices. If n equals to P, that means the number of column of A equals to number of rows of B. Number of column of A equals to number of rows of B. If n equals to P, then AB can be defined. AB can be defined. Similarly, if Q equals to M, then BA can be defined. BA can be defined. If M equals to P and Q equals to N, then both AB and BA can be defined. The order of AB will be M cross Q. That is the minimum condition. Any two matrices cannot be multiplied with each other. That is the minimum condition, that whenever we multiply two matrices, we have to find whether that satisfied this condition or not. The number of column of first must be the number of rows of second. Then A can be multiplied with B. Before the multiplication, we have to watch this condition. Then we can multiply these two matrices. Then how we multiply? Suppose A is a matrix 1, 2, 3, 2, 1, 3, 1, 2, 1. This is a matrix of order 3 cross 3. And B is a matrix 1, 2, 2, 1, 1, 1. This is a matrix of order 3 cross 2. Now we can multiply A with B, but we cannot multiply B with A because here the number of column is 3. Here is also number of rows is 3. So we can multiply A with B. But the number of column with B is 2, but the number of row of A is 3. So B cannot be multiplied with A, but we can multiply A with B because the number of columns of A equals to number of rows of B. So AB can be defined. How we can find AB? When we multiply A with B, first we select the first row of A with first column of B. First row with first column, corresponding element to corresponding element. 1 into 1, 1 into 1 plus 2 into 2 plus 3 into 1. That is the first element of the AB. Similarly, first row, second column, 1 into 2 plus 2 into 1 plus 3 into 1. First row, first column, first row, second column with corresponding element to corresponding element. Next, we go to the second row. 2 into 1 plus 1 into 2 plus 3 into 1. Second row, first column. Similarly, second row, second column. 2 into 2 plus 1 into 1 plus 3 into 1. Second row finish. Next, third row. 1 into 1 plus 2 into 2 plus 1 into 1. Similarly, third row, second column. 1 into 2 plus 2 into 1 plus 1 into 1. After the simplification, 1, 4, 5, 3, 8. 2 plus 2, 4 plus 3, 7. 2 plus 2, 4 plus 3, 7. 4 plus 1, 5 plus 3, 8. 1, 4, 5 plus 1, 6. 2 plus 2, 4 plus 1, 5. This is a matrix of order 3 cross 2. That is the multiplication of the two matrices. Very important. How to multiply two matrices? That is the process to multiply the two matrices. And there are fundamental properties. First properties, matrix multiplication is not commutative in general. That means AB is not equals to BA in general. In particular cases they may be possible, but in general AB is not equal to BA. Number 2, but matrix multiplication is associative. A into BC equals to AB into C. Next, matrix multiplication is distributive over addition. A into B plus C equals to AB plus SC. Number 4, AB transpose equals to B transpose A transpose. Not A transpose B transpose. That is a very important properties. Number 5, transpose of unit matrix is same as unit matrix. These are the basic properties of the matrix multiplication. Now you can go through the exercise, first exercise of your books. That is exercise number 4A. 4A exercise you can complete. There are 43 number of problems. There is a very task, important task also. You have to complete 44. Number of problems is 44. Go through your elements book and complete the exercise number 4A. That's enough. Thank you all.